ABCI is the contract between CometBFT consensus and your Cosmos SDK application. We'll begin with the original block flow, then look at how ABCI++ gives applications more control over proposals, vote time data, and faster, more flexible commits. We've already mapped the Cosmos stack: zones, hubs, the SDK, modules, IBC, and CometBFT. Now we'll zoom in on the key boundary between consensus and application logic, ABCI. Understanding this contract prepares us to build and run a real chain next. ABCI lets CometBFT and a Cosmos SDK application focus on separate responsibilities. CometBFT handles networking, validator voting, consensus rounds, and final agreement on blocks. The application decides what transactions mean, decoding them, checking rules, executing module logic, updating state, and returning a commitment. Through calls like CheckTx, DeliverTx, commit, and query, ABCI keeps that boundary clear. So many applications can reuse the same reliable consensus engine. Classic ABCI organizes communication by purpose. The consensus path is the critical path. It executes blocks and produces committed application state. It begins with InitChain at Genesis, then moves through BeginBlock, DeliverTx for each transaction, EndBlock, and commit. The mempool path is separate. CheckTx screens transactions before they are proposed. Query calls read application data without driving consensus. Together, these paths keep execution, admission, and reads distinct. In the classic block lifecycle, CometBFT chooses the block order, then calls the application through a fixed sequence. InitChain runs once at Genesis. For every block, BeginBlock opens execution. DeliverTx applies each transaction in order, and EndBlock computes final block-level changes. Commit persists the new state root and returns the app hash. That hash is carried forward by consensus, proving that every honest node reached the same deterministic result. InitChain is the chain's starting handshake between CometBFT and the application. At Genesis, the app loads accounts, balances, module settings, governance rules, consensus parameters, and the initial validator set. From that exact input, it creates the first application state commitment, the baseline every node must share. The critical requirement is determinism. If two honest nodes read the same Genesis file, they must produce the same starting state and app hash. At the start of each block, BeginBlock runs block-level logic before transactions are processed. This might handle evidence, update module state, or trigger scheduled actions. Then DeliverTx runs once for every transaction, in the exact order selected for the block. Each call reads state, applies deterministic changes, and emits events. Those events make execution observable, while determinism ensures every node reaches the same final state. Once transactions are complete, EndBlock gives the application a final chance to close the block. Modules can settle deferred work, such as rewards, slashing, accounting, or cleanup. The app can also emit validator updates that affect future consensus participation. Commit then makes the results durable by writing state to storage. The returned app hash is the cryptographic fingerprint of that final state, and CometBFT records it as consensus-critical evidence of what was committed. Classic ABCI creates a disciplined back and forth. CometBFT owns the block lifecycle. It proposes, votes, finalizes, and commits a block. The application does not choose the block contents. It executes what consensus has selected. For each transaction, it returns results and events, followed by any validator changes and the new state hash. Because every honest node runs the same sequence, safety depends on the application being fully deterministic. Classic ABCI worked well. Consensus chose the block, the application executed it deterministically, and state was committed. But that clean boundary also became a ceiling. The app had limited influence over which transactions formed a proposal, how mempool choices reflected application logic, or what extra information validators could attach to votes. As chains became more specialized, they needed interaction earlier than execution, including proposal shaping and consensus time application data. ABCI++ expands the conversation between consensus and the application. Instead of only executing a block after consensus decides, the app can help prepare proposals, evaluate whether proposed blocks are acceptable, and attach application-specific data through vote extensions. This gives chains more control over ordering, inclusion, and validator signals while preserving the core separation of responsibilities. Consensus still coordinates agreement. The application gains richer, earlier points to express chain-specific rules. Proposal handling is where the application gets a voice in block construction. The proposer starts with candidate transactions. Before voting begins, Prepare Proposal can filter spam, reorder transactions, or choose a subset that fits the app's policy. The resulting block is sent to validators. Each validator then runs Process Proposal to deterministically inspect the proposal and accept or reject it. The key rule is safety. Every validator must reach the same conclusion from the same block. Vote extensions let validators attach application-defined data to their pre-commit votes. Extend vote creates that payload, such as an oracle price, fraud alert, cross-chain hint, or threshold signal. Before another validator accepts it, verify vote extension applies the app's rules and rejects malformed or unsafe data. Because this metadata travels with consensus votes rather than normal transactions, verification must be deterministic and conservative. This is where ABCI++ becomes practical. A DEX chain can build blocks around market rules, not just arrival order. A high-throughput chain can prioritize fees, urgency, or policy. Validators can attach fraud hints or data availability observations to votes. Specialized apps can also define proposer behavior for batching, oracle updates, or custom sequencing, without forcing everything into transaction execution. ABCI is the contract that lets CometBFT drive deterministic Cosmos SDK state changes. Classic ABCI executes blocks through BeginBlock, DeliverTx, EndBlock, and commit. ABCI++ extends that lifecycle with proposal and vote hooks, enabling smarter block building and validator coordination. Next, we'll turn this understanding into a working chain.